All right, so that means her chubby's dad's parents, her grandparents, um, because they're both big M, big M, right? And if you do the Punnett square for chubby's paternal grandparents, it's impossible for them to have any children um, that have any little m alleles, okay? Because if you look at the Punnett square, they're all big M. So that means Chambi's father, his genotype has to be big M, big M, okay? So for Chambi's mother, okay, um, her parents, it says her paternal grandfather had Mark's disease, right? So he's little m, okay? Um, we don't know what her grandmother on her mom's side, her maternal side, um, what do you call it, alleles are, okay? But we do know that the mom, Chambi's mom, does not have Mark's disease, okay? So that means um, the maternal grandmother cannot have the genotype little m, or that would 100% guarantee that Chambi's mom has Mark's disease, and that's not possible because it says right here, Chambi's parents do not have Mark's disease, okay? So let's just say that the mom is, big M, little m. Okay. Um, if we do the Punnett square, that that means it's possible that um, Chambi's mother's parents could have children with Mark's disease and also have children without Mark's disease. Okay. So if this is the case right here, that means Chambi's mother her genotype has to be big M, little m. Okay, the reason why it can't be little m is because then she would have Mark's disease. Okay. So, um, what does this mean? Okay, now that we have the father's genotype, and now that we have the mother's genotype, okay, we do the Punnett square. Okay, and big M here, little m there. Okay, and then her mother is, or sorry, her father is big M, big M. So if we do the Punnett square, one of these four, okay, in the Punnett square, is going to be Chambi. Okay, you can see by the Punnett square, it's impossible for Chambi's mother and father to have any children with um, Mark's disease. Okay, so at the worst, Chambi has big M, little m, so she doesn't have a Mark's disease. I mean, she is a carrier, meaning that she carries the little m allele for Mark's disease. Okay, so it's possible that maybe her children could get Mark's disease, but she herself cannot have Mark's disease because the only possibilities are she's big M, right? Or she's big M, little m. And both of those are normal. Okay, next question. So now we're going on to incomplete dominance. Okay, we're still looking at autosomal chromosomes. So we're still doing a normal type of Punnett square where there's, but this time there's incomplete dominance. Um, when you have a let's say like big R allele and the little R allele, right? Then you'll end up with a color, um, in this case for the beetles, but something in between. So what's in between blue and red is actually purple. So like, let's say that you have an individual, if this is incomplete dominance, and again, the problems will always state if it's incomplete dominance, a codominance, a sex-linked trait, or like just like a regular Punnett square. Okay, so if an individual is big R, little r, okay, they're actually going to have a purple beetle color. Okay, so the problem says cross a red beetle with a blue beetle. Okay, so the thing with it's pretty much set up the same way, okay? But in this case, all the heterozygous genotypes will be purple, okay? So a beetle that is red in color for incomplete dominance Punnett squares has to have the genotype big R, okay? Because if that beetle is big R, little r, then it would be purple in color, okay? So we'll put that one on top. So big R, okay? The Punnett square. And then with a blue beetle, and then so they have to be little r, little r. You do the Punnett square, okay, and then you show the genotypic ratios. Then you have for big R, little r, okay, and then for the phenotype, you have for purple beetle colors. Okay, so let's go ahead and try this part on your own. Okay, so number 6 says flower store owner Katie wants more pink flowers. The pink flowers in flowers, this should say are, sorry, improper grammar, are an incomplete dominance between red flower color and white flower color. In order to ensure the highest chances of getting pink flower baby plants, what should the genotype of the adult plants be? Okay, use big R for red color and big W for white color. Okay, so go ahead and press pause and solve it on your own. All right, so now we're going to solve this. So we want to make sure, so Katie, it looks like she wants pink flowers, right? So we want to make sure to try to make it so the Punnett square is going to have all big R, little r's, okay? Because big R, little r represents pink, okay? Because this is an incomplete dominance, and the thing that's between red and white is pink, okay? So in order to do that, you know, one of the flowers has to be big R, and the other flower has to be little r, little r. Okay. If it's like that, then 4 out of 4 of those boxes are going to be pink flowers, so that's 100%. So if you cross a red flower with a white flower, and this is incomplete dominance, then 100% chance that you're going to have baby flowers that are pink, okay? Something else that would not be as successful would be like if you were to use a pink flower plant, okay, and you cross it with like a white flower plant, only 50% of the baby flowers would be white. The other ones would be pink, and the other 50% would be white. Okay, so this one right here gives you the best chance. Okay, so now let's move on to codominance. Okay, so for codominance, this is when if you have 2 different alleles, right? So in this case, big R is for red, big B is for blue. Then in codominance, you actually end up showing both the red and the blue. So you might end up with a striped red and blue beetle, or maybe like one side of the beetle is red, the other side is blue. But basically, both of those alleles, both of those colors will show. Okay. So in this example says cross a heterozygous red beetle with a homozygous blue beetle. Okay. So let's do the Punnett square. Okay, so homozygous red, homozygous means two of the same allele, so big R, and then homozygous blue, so that's big B, so big B, big B. Okay, if you flip it the other way and you put BR instead of RB, then that's the same. Usually we go to in alphabetical order. So if you do like um, BR, BR, like that, they're exactly the same thing. Okay. So looking at this Punnett square, basically you end up with four of the Punnett square boxes that are going to be heterozygous, um, you know, RB. Okay, so we're looking at this one. Yeah, the genotypic ratio. Genotypic ratio would be 4RB, and the phenotypic ratio would be 4 red and blue, like that. Okay, so now we're going to go to our try it out part 3. So Truman loves Siberian Huskies. He especially likes Huskies with blue and brown eyes. He currently has a male Husky that has 2 brown eyes and a female Husky with blue and brown eyes. Assuming that the big B allele for blue is codominant to the big R allele for brown, what are chances of Truman having puppies of that have blue and brown eyes? Okay, what about only brown eyes? Okay, so let's go ahead and do the Punnett square. Oh, sorry. Press pause and then go ahead and try this on your own. Okay, so now let's solve the problem. So he has a male husky that has 2 brown eyes, right? So that means the alleles for that male husky is big R, big R. Okay, and then he has a female husky with blue and brown eyes. So that means she has one big B allele and one big R allele. Okay, and then so we do the Punnett square. Okay. So, and then question asks, what are chances of Truman having puppies with blue and brown eyes? Okay, so blue and brown would mean that they have the big R allele for brown and the big B allele for blue. So that is this one and this one. Okay, so 2 out of the 4 Punnett squares would be 50%. So 50% for blue and brown. Okay, and then the other two, big R is for just brown, 2 brown eyes. That's 2 out of 4, so 50% for brown eyes. What this means is if he has the two huskies, the male and the female, have puppies, 50% of those puppies should have blue and brown eyes, and another 50% should have brown eyes only. Okay, so now we're going to move on to multiple allele Punnett squares. And this particular example is going to be a blood type. Okay, so the thing that with blood type is you need to first understand like how blood type works. Okay, so if we say A blood type, what that means is the A blood type is a phenotype, meaning you have A blood. Okay, the genotypes that create that A blood, that trait, genotype meaning the alleles is AA or AO. Okay, for B blood type, you can have the genotype BB or BO. Okay, for AB blood type, you have to have the A and a B alleles. Okay, so what this tells, and then for O blood type, OO alleles are the only thing that create O blood type. So what this tells us is that A is dominant over O blood type. Okay, so as you can see that AO alleles still creates A blood type. So that means O is recessive, A is dominant. Okay. In the case of B and O, same thing. B is dominant over O. Okay. For this AB blood type right here, you see that there's alleles A and B. What that means is A and allele B are codominant to each other. Okay, so they'll both be showing. Okay, and the O blood type, because it's recessive, only way possible is if you have two O alleles. Okay, so it says cross the AB blood type person and an O blood type person. What are the chances of having a child with A blood type? Okay, so let's go ahead and do the Punnett square. Okay, so draw the Punnett square. A, B, O, O, so that's O. Okay. So if you do this, it says what are the chances of having a child with A blood type? So right here we have two AOs. Remember that AO genotype still creates A blood type. So 2 out of 4 of the Punnett square boxes have AO in it. So 2 out of 4, that equals 50% chance for A blood type. Okay, let's move on to the next one. Cross a blood type person with alleles A and A with a heterozygous B blood type person. What are the phenotypic and genotypic ratios? Okay, so an A blood type person with alleles AA. So let's put them on the top of the Punnett square. Okay, with a person that has heterozygous B blood type. So that means they have two different alleles, but still B blood type. So BO. Okay, so you do the Punnett square. So genotypic ratios. To a B and to a O. Okay. Phenotype are phenotypic ratios. To a B blood type and to a blood type. Okay. Okay, try it out part 4. So Elizabeth learns in Mr. Han's biomed class that O blood type can be sold at blood banks because it is considered a universal donor and is in high demand. Unfortunately, she is not sure what her blood type is. She knows that her mom is B blood type and her dad is A blood type. Is it possible for her to be an O blood type? Okay, so go ahead and press pause and solve it. And then now we're going to solve it right here. Okay, so okay, if you're B blood, right? The possible genotypes that you can be is BB or BO. Okay, if you're A blood type, you can be AA or AO. Okay, so here we could do all the possibilities, but there is like a shortcut to this. Okay, so she wants to know if it's possible for her to be an O blood type, right? In order to be an O blood type, right? In order to be O blood, you have to have OO alleles. Okay, so if her dad is A, there's no way he's giving her any O's because he doesn't have any O's. Okay, if her mom is BB, there's no way her mom is giving her any O alleles because she doesn't have any O alleles. Okay, but if her mom is BO, it's possible that the mom can give the O allele, right? And if her dad is AO, then it's possible that her dad could give her the O allele. Okay, so we are going to go with these two genotypes for her parents, just because that probably gives her the best chance. Okay, so let's assume that her dad has alleles BO and her mom has alleles AO. Okay, so and again, if you want, it's probably easier to put things in alphabetical order. Okay. If you look right here, so 1 out of the 4 um, squares in the Punnett square is OO. Okay, so 1 out of 4 is 25%. So if Elizabeth's parents have the genotype BO and AO, then she has a 25% chance of being OO or O blood type. Okay, that's it. So 1 in 4 chance.